ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮಣಿಭೂಷಣ್ ಡಿಸೋಸ. ನಾವು ಲೈನಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ನ ಬಗ್ಗೆ ಹಿಂದಿನ ಕ್ಲಾಸಿನಲ್ಲಿ ಕಲಿತಿದ್ದೇವೆ. ಇಂದು ನಾವು ಸೆಷನ್ 16 ಇದನ್ನು ನೋಡಲಿದ್ದೇವೆ. ಇಂದಿನ ಸೆಷನ್ನಲ್ಲಿ ನಾವು ಫೈಲ್ ಸಿಸ್ಟಮ್ ಅನ್ನು ಹೇಗೆ ಮೌಂಟ್ ಮಾಡೋದು ಮತ್ತು ಅನ್ಮೌಂಟ್ ಮಾಡೋದು ಇದರ ಬಗ್ಗೆ ಕಲಿಯಲಿದ್ದೇವೆ. The learning objective of this particular session is to understand the process of mounting and unmounting operations of the file system. In order to understand this concept, it is advisable that the viewer has a basic knowledge of UNIX file system. We are familiar that an existing physical disk is logically divided into many sections. For example, if I look at my Windows system, in my laptop I have only one disk, but I have divided that disk into logical section. That is why in Windows I have C drive, D drive and E drive. All of them resides in a single disk, whereas I also have a CD-ROM in my system. This is a separate device. Now when it comes to the UNIX system, whenever we are using a device, we assign it a number. For brevity, let me just give it as a number 1. And for other device, we give the unit number as 2. So the entire hard disk, the physical hard disk that I have in my system is numbered as 1, whereas the physical CD-ROM drive is numbered as 2. Within this hard disk, I have partitioned it logically into 3 other sections. So I am going to number the first section as 1, let's say, and let me number the second section as 2, and let me number the third section as 3. Now in order to read the content from this, if I use the numbering system, then I will have to read it as 1.1. So that will be the first device. Similarly, if I want to read from this device, suppose if I have to read from this device, let's say, then I will have to use the number 1.3. So if you look at the numbering system over here, so this is called as a major number, this is called as a minor device number. So there will be 2 device numbers which are associated with a particular device. One is the major and the other one is the minor. Now let's come back to our PowerPoint presentation. So a physical unit may consist of several logical sections partitioned by the disk driver. Now in UNIX we know that every device can be considered as a file. So including our disk is a file. So the process can read the data from any section of this particular disk by using that file. So let's look at this in action. Suppose if I go to the Ubuntu and will just log into my Ubuntu. I think I pressed the wrong password. Yeah. If I log into my UNIX operating system, and then if I open the file system, you will notice that I have 2 additional devices. One is the virtual CD drive and the other one is the pen drive that is connected to my UNIX file system. Now all of them are mounted on the file system. So if I look at the file system here, so if you look at the whole file system here, so there will be two devices that are connected to my file system. So if you notice here, I have this pen drive and you have this CD-ROM, right? Now in the Unix, there is a one special folder called as dev, which contains devices. Now you notice that this particular section consists of many files. Like if you want to access block files, so you have some files associated with them. Now these are the files that represents the devices. So if you look at other files over here, so you may have the file that represents the disk, okay, and so on and so forth. Okay, so let's come back to our presentation. If at all I want to make use of a disk in the Unix file system, then that disk that I'm talking about is associated with the file. So a process has to first access this file. Once it opens this particular file, it can write to this file, which in turn will write to the disk. In the same way, it can read from the file, which in turn will read from the disk. So even though disk is a physical device, we are reading and writing from a file. So we can treat that file as a block of as a disk block or a sequence of disk block, and then start reading the content of a file. Whenever we create a file for the device, the kernel checks whether such a file exists. If such a file does not exist in the system, like the regular file, it creates a new file, okay, with the name that you have specified and with the permission like read only or read write mode. Then you can already use it. Suppose if the file already exists, like all the regular files, it truncates the file, releases all the data blocks of the file and sets the size to 0, and also sets the permission for the file as that given by the user. Now when we look at a particular file system, we may have a different types of file system. Now we know very well most of our pen drives have FAT32 or NTFS or this kind of file systems, whereas the Unix may use extension 4 or extension 3 or Razor FS, this kind of file system. Now we need to connect this file system to our existing Unix file system. What do I mean by that is, when I look at my Unix file system, my Unix has already a file system which is arranged in a hierarchy. You can see the hierarchy of the Unix file system. If I go here and then okay, you can see the hierarchy. This is an older Ubuntu, so you may not see the exact hierarchy, but you can you have the idea of Unix file system, wherein you have the root here. Under the root you have the many other folders, and under them we may have still many folders. So all of them are connected. So you get a hierarchical structure. We are all familiar. We have already seen this thing in the previous chapters. Now when we try to connect some other devices, those other devices has to be connected to some point within the hierarchy, either here or maybe for the root itself. You can connect the other file system anywhere. So the point where we are going to connect our other file system like our pen drive or CD-ROM or maybe other external hard disk, this point is called as a mount point. We are going to mount the external file system to this particular point. Okay, for example, if you look at my pen drive, even though I can see the pen drive over here, if you look at my pen drive is connected to a place called as a media. Within that I have money. Within that I have the pen drive. So this is my pen drive that I am connecting. Okay. In the same way, my CD-ROM is this one. So the content of the CD-ROM is actually, so even though I see over here in a GUI, it's actually connected to a media folder. So it is, if you want to see the hierarchy is you have the root, under root many things are there. Under root you may have many things. One of the thing, so under the root you have many things. Okay, you may have many things under the root. Okay, so like say and so on and so forth. So you have media. Under this media you have money. Under this money you have CD-ROM. So it is mounted at a point called as money. Okay, just to show you, which is inside the media. So if I open this media, there will be money. Inside money I have the CD-ROM. Okay, you can see the content of that. Okay, so we are able to see that thing. Let's come back to the PowerPoint now. So whenever we want to connect a file system, that is the external file system like our CD or our pen drive, we call that as a mounting. So we have to mount the file system into the existing file system. So we can use the mount system call to connect the file system at a particular specified section within the disk of our existing file system hierarchy. This allows the user to access the data in the disk as the file system. So when I connect my external file system, in other words, if I mount an external file system, that becomes a part of the existing file system, and then we can directly access the content of this particular file system as though we are accessing the existing file system. The system call for the mount is as follows. So we use the word mount, which is the keyword. So we use the word mount. Then we need to specify the special file, that is the file that is associated with the device. Then we need to specify the path where the existing file has to be, or the existing directory where the file system has to be mounted, and this is called as a mount point. And then we can specify the option. The option generally includes whether we want to read the content as a read only or in a read write mode. Okay, whenever we create a mount, the Unix file system creates a mounting table that contains a lot of entries. Okay, these entries include the device number, that is the number that identifies the file system, that is the logical as well as the physical unit, that is a major number and the minor number. Then a pointer to the buffer where the super block of the file system will be used, and then we have a pointer to the root of the mounted file system, as well as we can also have a pointer to the inode of the directory, that is the mounting point. If you look at this particular example over here, we have an existing file system with all the content over here. Now I am trying to mount a file system, a new file system into the existing file system. In other words, I'm going to connect my, let's assume that this is my pen drive. I'm going to connect my pen drive to the existing file system. The point where I connect, this is my existing file system, that let's say this is my Linux file system. The point where I want to connect the new file system, or a point where I want to mount the new file system, is user. So I specify that thing here. So this is the mounting point where I want to connect the file system. Now the existing file system may also have its own hierarchy. So which part of the existing hierarchy I want to connect? So in this particular file system, let's say, also has a root. Suppose if I want to connect this root into user, then I'm going to say that I want to connect the dev.disk1, the root of dev.disk1, to this mount that disk to this particular location. So that is the idea. Okay, let's look at that in action. So if you look at the three parameters over here, so the first parameter indicates the special file name, that is this one. This is the special file name, that is under dev we have the disk1. I have already shown you. If you go to the Unix file system, okay, we have dev here. This contains many files. So this may contain one of the file, like maybe one file is there, let's say this file. So if this is actually a pointer, but let's assume that that's the file there. So this is that special file that I'm talking about. Okay, so you notice that this is a block device file. So link, it's actually a link to the block device file, but you can get that thing. It is a block file. It's actually referring to the actual location is dev.disk by label. So this is the location where this exists. The target is SR1. So 2 times up and SR1. So if I go here, so if I go here, 2 times up, and that is dev, and you will notice that particular file SR1. So under dev, let me go to the dev, and you have many things there. Let me go to the ES there. Okay, not this one. Just a second. Have to go to the X here. Okay, where is? That's it. Yes. If I search for yes, the content of, you can notice over here You have ESDB, ESR. So these are the files that we are talking about. So it is actually pointing to a file. I think I have removed that properties, but anyhow, you get the idea. It is actually pointing to one of that ES that we are talking about. That is a bulk device. So if I go to my computer and then to media and then to money and then to a particular file. Okay, this is the existing file, but it is pointing to a particular device. So let's go back to the PowerPoint over here. So this is the device file that I want to connect to the user location within that, and then you can specify whether you want to make it read only or read write. Once we have connected that, we can always unmount the file system. Now in Unix, before I go to the unmount, let me show you. Now you notice over here that I have my CD-ROM drive, which is the device slash ESR0. This is the read only. It is mounted at media.money. You can notice out here. And then I have my pen drive, which is dev.esb1, and it is mounted at media.money. Some other location. Now if I have a command called as ls bulk, that is ls blk, if I use that thing, it's going to show me the various devices which are part of my system. Now if you notice that SDA is the major number, that is my bulk devices. Under that I have one device called as SDA1, which is mounted at the root, and the major number for all of them are 8, and this 8.0 means the entire device. Okay, under that the first device will be 8.1, the next device is 8.2, and the next device will be 8.3, and I have my CD-ROM, which I think this is the CD-ROM, CD-ROM which is having ESR0, and I have my pen drive which is this one. So you notice that there are for block devices, it is using one major number and it is using one minor number, and maybe you have the size, but you can also see the mount point. So always you can use in Ubuntu, you can use ls bulk to get the file system. Let's go back to the unmounting now. So once we have used the content, and when we don't want to use, like if I want to disconnect my pen drive from the Windows, what we usually do is we are going to right click and say eject the pen drive. In the same way, when we talk about a Unix file system, if we don't want to use the file system, we can unmount. So mounting is to connect, unmounting is to disconnect from the file system. So when I connect my pen drive to the Unix file system, we say that is we are mounting the pen drive, and when we are removing the pen drive out from the Unix file system, we say unmounting the devices, any devices for that matter. It could be pen drive, or it could be your CD-ROM, or it could be your external hard disk, or anything for that matter. So how do I unmount the file system? To unmount it, you just say unmount and specify the special file name that you want to unmount. So your command is very simple: unmount followed by the name of the file, that special file that you are using. Now there are a few things that you must understand that the Unix is doing. When you say unmount a file system, so Unix is going to access the inode of the device that need to be mounted. Remember why this inode has come into picture. I've already told you, in Unix everything is a file. So a file is associated with the inode. So that is It's like a default statement, so always you remember that everything is a file, and a file has to be associated with the inode. So when you unmount it, the Unix, what it's going to do is it's going to go to the inode. Okay, so it's going to retrieve the device number. I have already shown you that device number. It's going to release that inode, and then it's going to go to the mount table entry. So you must understand that every device that you are going to mount in Unix will have a entry in the mount entry table, wherein you are going to, it's going to specify the devices that are being mounted. So for example, every device that are being used, there is a table here that indicates which devices are being mounted. So you must understand that thing. So that is true in the Unix file system. So every uh, device that is mounted has a mount entry, and whenever we want to unmount it, the the kernel will go to the mount table and it's going to release its content. But one important thing that you must understand is, before the Unix system unmounts your file system, it will make sure that no files within that particular device is still being in use. So this is true even in the Windows. When you might have observed, when you try to eject your pen drive, you may get a warning message from the Windows saying that the device is in use. What is the meaning of saying device is in use is some of its file, one or more of its file is already active. So you have already opened it, and but you have not closed that thing. So if you don't close it, what is going to happen is, and if you remove the pen drive, you may lose the data. So that should not happen, is it not? So that is true even in the Unix file system. It will check whether that file is being used. So you know very well, whenever we use the file in the inode, we make the entry 1. So we indicate how many people are using the same file. If the count is 0, count is 1, and when we decrement, if the count becomes 0, nobody is using. But if the count is more than 1, that is positive number, somebody is using. So if the file is active file, so if any of the file is active within the device, that means some files are been opened but it is not yet closed, then the unmounting will fail. So unmounting will not proceed. The next thing about the unmounting is, we know very well in Unix we have the concept of delayed writing. So we don't directly write to the disk. We keep the content in the buffer, and then leisurely we write to the disk. Now this is the buffer tool. Now if we simply unmount it, and if there is some content in the buffer full which is not yet written, and if we disconnect, what is going to happen is the content may be lost, because you have the content in the buffer, it is not transferred to the disk. So before the disk is unmounted, the content of the buffer is flushed back to the disk. At the same time, when we are using the disk, disk, or it could be a pen drive also. I am just showing the content of the disk because it is easier for me to draw. Now the super block of this disk, you know that there is a in-core super block that is there in the RAM. That may get modified, because you might have allocated some of the blocks, or you might have released some of the block. So there is always a chances that the content of the super blocks might have been changed in that is the in-core content. Now before the disk is mounted, the content of the super block has to be written to the disk. Okay, so it will transfer all the content of the super blocks to the disk. Okay, then it releases also the inodes. Okay, update all the inode copy and releases the inode. Once it has rewritten the super block, that is, it has released the inode, it has written all the content of the buffer into the disk, it invalidates the buffer and then goes to the inode, and then sets or clears one of the flag called as mounted on flag of the inode. With this, the file system is completely unmounted. Okay. Now, before I go, I'm going to just show you now, because I'm using a virtual device, I cannot directly do it, so I cannot unplug it. So I'm going to go over here and then try to remove my pen drive. Okay, when I remove my pen drive, it's removed from the disk. You can notice over here, it is removed from here. If I again use the same command, you notice that this pen drive is there here. Okay, this pen drive is there, and now you notice that that pen drive is gone. So this pen drive was connected. This is a, you can take it as the mount table there. So from the mount table, that is unmounted from the device. Okay, so you get that idea. I have not typed the unmount command because Ubuntu will automatically unmount it when I do it, because I'm using the virtual machine over here. When I release the device, Ubuntu will automatically unmount it from my device. So that's all how to mount and unmount. We will meet again in the other class. Thank you for your interest.